Cards are dealt from a well shuffled deck. What's the probability of getting all hearts? So,
So 5 out of 52. Yeah.
no.
5 cards.
Wrong. So, no, you're making 5 draws.
Yeah.
So, what's the probability that your first draw is going to be a heart?
1 out of 13, or 1/4.
1 and 4, because there's 4 suits, one of them is a heart. So instead of writing 1 and 4, I'm going to write 13 and 52. I'm not going to reduce it yet because there's a reason, you'll see in a second. What's the probability that the second, so you've drawn 1 card, and it's the heart, I guess. So what's the probability that the second card you draw is a heart?
Total 51.
Right. There's 12 hearts left, and there's 51 cards left. Now, why am I putting them all in one fraction? Because remember, when you want simultaneous events, you just multiply them all together. So it's just like one big fraction. Okay, what's the probability that the third card will be a heart? Okay, there's 11 hearts left, 50 cards left. So it just goes down like this. And we're drawing 5 cards. So do you guys, they're going to ask us, this would give us the answer, but they're going to ask us this later on. Oh, actually they didn't even multiply this out. How could I write this with factorial? How could I write 13 all the way down to times 9 with factorials? It'd be 13 factorial divided by what? How do you get rid of the 8 times 7 times 6?
8.
You divide by 8 factorial. Alright, that'll give us the top. 13 factorial divided by 8 factorial will give us the top. Now how would I get the bottom? The bottom is like 52 factorial. But how do I get rid of 47 factorial? So I put it on top. Because that would cancel out with 47 factorial on the bottom. Does that make sense?
Mm-hmm.
Leo?
Yeah.
That was your lie, yeah.
That makes, no, it doesn't.
Okay. Alright, let's back up a step. What's 13 factorial mean?
13 times 12 times, yeah. Nice.
Okay. What would happen if I divided that by, like, let's say 10 factorial? What would happen?
Cancel out what the 10 and
Right. Yeah. So the 10 times 9 times 8 would cancel out with dividing by 10 times 9 times 8, blah, blah, blah. So it would just leave the 13 times 12 times 11. Okay, so how could I write this in factorial form? Well, this is 13 factorial, but you have to take out 8 factorial. That's where that came from.
Okay.
And on the bottom, it's kind of the same idea. The bottom has 52 factorial. Take out 47 factorial.
That makes more sense.
Right. Blink, blink. You don't really have to put those times. Some calculators you might have to, but we're just going to leave it like that. 1A. It'd be a really messy fraction.
Yeah.
If you're going to put anything, you probably want to put a decimal, but they didn't. They just left it like that. So, because it's kind of a mess. Or percent. A percent would be a good way of writing these. Okay, what's the probability of getting no hearts? So what's the probability that your first draw is not a heart?
39 out of 52.
Right, 39 out of 52. So there's 13 hearts, and there's 13 times 3 not hearts. So that's 39 out of 52. And then what's the probability of, so the second one being not a heart is 38 out of 51. Okay. And then there's 5 draws. Engage brain. Alright. So how do we write that in factorial form? The top would be 39 factorial. Whoops, I don't know what my brain's done. And we're taking out 34 factorial. The bottom would be kind of like A. The bottom is 52 factorial. And we're taking out 47 factorial. Shh. This is the old days when you gave me death stares. Now you just tiredly blink at me. Okay, at least one heart. Okay. This is more like yesterday's. Do you guys remember what we did yesterday?
You have to find all the combinations so we can go.
Okay, yeah, so.
You do that in multiple for 5.
Oh, well, wait. It didn't say one heart. Back up. I made a mistake.
At least.
It said at least one heart, so there could be one heart, two hearts, three hearts, 4 hearts, 5 hearts. So the probability of getting no hearts was what we just did right here. So how could we find the probability of getting at least one heart?
Could you add the two probabilities together?
No.
Okay.
Okay, there's two. You could look at this as there's two possibilities. You could get hearts, like one or more, or you could get no hearts. Those two possibilities should cover every probability, right? You could get no hearts, or you could get 1 or 2 or 3 or 4 or 5 hearts. So together, those should cover all the gamut of possible outcomes. So what should they add up to? 1. The probability you're getting no hearts, or at least one heart, is 1, because that's the only thing that could happen. You could get no hearts, or you could get 1 or 2 or 3. So altogether they should add up to 1. So if the possibility of getting no hearts is whatever this is, how could I find the possibility of getting not no hearts?
That minus 1.
Well,
1 minus that.
1 minus that, yeah. It's kind of like, what's the probability of me choosing a boy in the class? I forgot how many did we have, like 5 out of 9, counting Katie. So the probability of me choosing a girl is 4 out of 9. They have to add up to 1. Anyway, because it's one or the other. Numeral trace. Let's make sure 2 is pretty much the same thing, yeah.
Except there's only one question.
No, 2 has 3 questions.
Can't count now. Oh, I can't read.
Number 3 you're looking at?
Yeah, I'm
A bag, there's actually 3 questions on 3 too. They just didn't put A, B, and C.
That's me.
Get your hopes up. A bag contains 5 red, 3 white marbles. If 2 marbles are randomly drawn, one after the other, without replacement, what's the probability of that the number of red marbles is 0? Okay, so 5 red, 3 white, which means 8 in total. And we're drawing twice. So what's the probability on my first draw that I'm going to pick out a, what was it, red? Red. What's the probability I'll draw a red? 5 out of 8. 5 red, 8 total marbles. Okay, it says without replacement, I'm going to draw again.
4.
So yeah, now there's only 4 reds left, assuming I'm having success. And 7. It was district of teens.
Mhm.
Okay, anyways, so this will be it. These will reduce, so it's gonna be 5 and wait, that's not right.
What?
Oh,
What?
I did the drawing 2 reds, so that should be my last answer. I should have started with drawing 0 reds.
Oh wait, is that for one?
No, that's okay, we'll leave it there.
That's what 3.
Okay, I did what's the probability of drawing 2 reds, which is one of the questions, but the first question they asked was actually what's the probability of drawing 0 reds.
Did you do 3 out of 8 then 2 out of 7?
Right.
Okay.
3 out of 8 cards or marbles are not red. So if you draw one of those, that leaves 2 out of 7 not red. So that's gonna be 3 out of 28. And then what's the probability of getting 1 red? Okay, this is more like yesterday. So let's say the first marble we draw is red. What's that probability? Okay, and then we need not red. So what's the probability that my second marble will be not red? Right, there's still 3, was it white? Marbles. But there's only 7 marbles in total now. Okay, so this is red, not red. What's the problem with this? Why isn't this the answer?
There's 2 different ways you can draw. You can draw red, white, or you can draw white, red.
Yeah, so it could also be white, red, which would be kind of the same thing. I mean, it would be 3 out of 8 to get a white, and then 5 out of 7, but it still ends up as 15 out of 56 because the tops and the bottoms are the same. But it's basically this times 2, which would be 15 out of 28. Easy peasy.
Why'd you have to say
I cursed you.
What was the third?
what?
What was the third answer?
Oh, we did that first. It
5
was
over 14.
Yeah, I did that. I accidentally did it out of order. Okay. Numero 5. Just push her out of the seat, Allison. Oh my gosh.
It's her turn, Mr. Jordan.
It's your time to be a star, Allison. Is that my last Kleenex?
you got it.
Free concert tickets are distributed to 4 students chosen at random from 8 juniors and 12 seniors in the school orchestra. Lots of numbers here. So 4 students are chosen from 8 juniors, 12 seniors. What's the probability the free tickets are received by 4 seniors? Okay, what is the probability that the first ticket will go to a senior? Well, there's 12 seniors
12
out of 20 students. Yeah. You could reduce that. It's not necessary though. Or if it was our final answer, you'd need to, but it's going to help us not to reduce it. What's the probability that the second ticket goes to a senior?
11 out of 19.
Right, 11 seniors left and 19 students left. And this goes down the line like that. 10 seniors left, 18 students. So that's probably 4 seniors. They put a fraction and a decimal. Which Which one do we want to do? I'd rather us just, you guys want to do decimal? Fraction? Okay, we'll do fraction. Okay. Was it 323? Okay. Second one. What's probability? Exactly 3 seniors. Okay, this is definitely more like yesterday's. So, if we want exactly 3 seniors, it could be senior, 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 junior. But what else could happen?
Who has a junior like right in the middle?
The junior could be in that spot, or that spot, or that spot. So there's actually 4 different ways this could happen. So we're just gonna find one way it could happen. Senior, 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 junior. And then just multiply by 4 and we should be good. Alright, what's probability a senior will get it on the first draw? 12 and 20. I'm just kind of copying that. So 11 and 19, 10 and 18. Okay, but what's the probability that a junior is going to get the last one?
8 out of 17.
Okay, there's 8 juniors to start with, and none of them have been chosen yet. So 8, and there's only 17 students left. Okay, well that's one way it could happen, but there's 4 different combos where that could happen. The junior could be the first, second, third, fourth. So we need to multiply this by 4.
352 over 969.
So you can see why they started putting decimals, because these are getting kind of crazy. Small fractions are more comprehensible, but decimals are always kind of the same. Number C, exactly 2 seniors. Okay, let's see. So one way that could happen is senior, senior, junior, junior. See if you guys remember from yesterday.
6.
How many different combos? If you have 4 spots choosing 2, there's 6 different combos. Yeah.
6.
We could do, yes, 6. So we could do 4 on the calculator to say there's 6. There's 6 ways this could happen. Could be senior, junior, senior, junior. Could be senior, junior, junior, senior. Anyway, there's 6 of them. Okay, first one is senior. Still 12 out of 20. Second one is senior. Still 11 out of 19. Okay, juniors, there's 8 of them. You guys like that, Jay?
Love it.
Love it. Improve. Now there's 7 juniors left and 17 students left. Okay, but there's 6 combos where this could happen. So we multiply by 6. Two, 2, 4, 16, 15. No. 16, 6, 16, 16, 15. Each of these is probably going to be worth 1 each. I'd say they're worth it. Okay, exactly 1 senior. Is that the same as the probability of getting exactly 1 junior? No, because the seniors are more likely than the juniors, so it's not really the same. Alright, anyways, the first one could be a senior. 12 out of 20. The second one would need to be a junior. There's 8 of those. Third a junior. Fourth a junior. Okay, how many different combos could we have? 4. Because a senior could be in the second, third, or fourth spot. Two, 2, 4, 16, 15. Okay, there's one more. We could do it the same way we've been doing all the rest. It's probably the easiest way. But do you guys know another way we could find the last one? No seniors?
That is all fractions for
Yeah, if we did 1 minus these 4, that would give us the answer. Because all 4 of these answers represent all possible outcomes. Well, all 5 answers would represent. So they should add up to 1. There's 100% possibility that one of these things would happen. Anyways, but we'll just go with standard junior. So there's 8 out of 20 juniors. Then 7 out of 19. Is there any other ways this could happen? No. Junior can't mix and match. Order doesn't matter. Okay.
14 over 969.
Easy peasy, right?